So this video looks at the division of complex numbers, and to be able to do that we need to look at what's called the multiplicative inverse. Now if z equals a plus bi, the multiplicative inverse, or z to the negative 1, which is also known as 1 over z, is equal to 1 over a plus bi. Okay, so that's pretty straightforward, but we don't leave a complex number in the denominator. Now, this is akin to surds, where we rationalize our denominator to make our denominator a rational number. So if we had 1 over the square root of 7, we times by the square root of 7 over the square root of 7. So in complex numbers, we do what's called realizing the denominator. So we make the denominator real. Now, in order to do that, previously we found that if we multiplied by our conjugate, so if we had z times by z bar, we ended up with a squared plus b squared, which was real. So that's what we're going to use here. If we multiply by our conjugate, we'll end up with a real number. So if we have z equals a plus bi, where z doesn't equal 0, our multiplicative inverse, which is 1 over z, which would be 1 over a plus bi, to realize that, we times by a minus bi over a minus bi. So our top is a minus bi. Our bottom is our z minus our conjugate, which we know is a squared plus b squared. So you don't need to do that the long way. It's just a squared plus b squared. Okay, if you forget that though, do it the long way. You have a plus bi times a minus bi. Our signs are the opposite, so we can just go a times a is a squared. Bi times negative bi is minus b squared I squared. You know I squared is negative 1, so that becomes a squared plus b squared. So in the box here, you can see that I've summarized that. So if z is a plus bi, the multiplicative inverse is z to the negative 1, which is a minus bi over a squared plus b squared, which is our conjugate over our modulus squared. Do you need to remember that? No, it doesn't take long to work that out anyway, as you just saw me do. Okay, so you don't need to remember that. So when we're dividing, we're going to use these principles. So Z1 over Z2 would be the same as Z1 times the multiplicative inverse of Z2. Again, yes, we could remember this rule. I personally wouldn't be. Okay, there's no need to try and memorize these things. It doesn't take that long to work them out. So I'm going to answer these without using the rules. I'm going to do them the long way. So first of all, we've got z equals 2 minus 5i. Find the multiplicative inverse. So z to the negative 1 is going to be 1 over z, which is 1 over 2 minus 5i. We're going to multiply that by 2 plus 5i over 2 plus 5i. So that is 2 plus 5i. This is one that I would definitely remember. So you've got 2 times 2 is 4, and then it's plus 5 times 5 is 25. It is definitely nice and easy to remember that. But again, if you don't, do it the long way. So you've got 2 minus 5i, 2 plus 5i. That's 4. You've got the opposite signs. So you've got 5 times 5 is minus 25i squared, which becomes 4 plus 25, which is 29. What I mean by that, a plus b, a minus b is a squared minus b squared. Okay, that's what I'm using. So if I've got z1 is 2 minus I and z2 is 3 plus 2i, find z1 over z2. So z1 over z2 is going to be 2 minus I over 3 plus 2i. I can't leave that complex number at the bottom, so I'm going to times by 3 minus 2i over 3 minus 2i. Work at the top. 2 times 3 is 6. 2 times the negative 2i minus 4i. Negative I times 3 minus 3i. I times negative 2i is positive 2i squared all over. And the bottom, we know it's just a squared plus b squared. So 3 squared is 9 plus 2 times 2 is 4. So that becomes bringing our like terms together. We've got 6 minus 7i. If you practiced your powers of I squared already, you could probably do this in one step, but remembering that's negative 1, so I've got minus 2, all over 9 plus 4 is 13, so that's 6 take 2 is 4 minus 7i all over 13. But you should be able to go from this step to that step. I'm just writing that intermediate step to make sure you can see where I'm at. Now this could also be written as 1 over 13, 4 minus 7i. And I should have, with this one, said that that's the same as 1 over 29, 2 plus 5i. Our last one, solve for z. We've got 2 plus 3iz equals negative 1 minus 2i. If we need z on its own, we're going to divide both sides by 2 plus 3i. So we end up with z equals negative 1 minus 2i over 2 plus 3i. And then we're going to multiply by the conjugate 2 minus 3i, 2 minus 3i. Our top, negative 2 plus 3i minus 4i plus 6i squared all over. First term squared is 4. Second term squared is plus 9. Our I squared is negative 1. So bringing things together, we have negative 2 take 6 is negative 8. 3i minus 4i is minus I all over 13, which we could write as negative 1 over 13, 8 plus I. Now you'll note that in your notes, I have provided the screenshots from the textbook on how to do complex numbers using your calculator. Make sure you go through and understand how to do that, because you may find it easier to do that in your Tech Active exam. So my recommendation when you're doing your textbook exercises is to practice checking on your calculator. So you're using your calculator to do these operations as well.